Let's discuss assignment operator in C#. Assignment operators are used to assign values to variables. So here int x is equal to 10. So we are assigning 10 value to x variable with the help of equal to operator. Here x plus is equal to 5, that is also represented as x is equal to x plus 5. So plus operator is used with equal to sign. So it is also called as compound operator. So x plus is equal to 5. It means x is equal to x plus 5. So these are the compound operators, compound assignment operators. So it can be used with equal to sign. So here this is simple assignment, x is equal to 5. Plus is equal to means addition assignment. Minus is equal to subtraction assignment, multiplication assignments, and so on. So there are also bitwise AND assignment, bitwise OR assignment, bitwise XOR assignment, and this is the syntax which is used in C# to use these operators. So let's understand these operators with the help of code. So in class program, we have declared static void main method. So in first line, we are declaring x variable which is of type integer and the value of x is 5. So we are just printing the value of x over here. After that, we are adding 3 value into x. It means that x plus is equal to 3 means 5 plus is equal to 3, that is nothing but 8. Again, we are reinitializing value x to 5 and then we are doing operation on it. X minus is equal to 3 means 5 minus 3, that is 2. So it will print 2 on console. So here we are again reinitializing x to 5. X into equal to 3 means 5 into 3, that is 15. So after that we are using division operator. So 5 divided by 3 is 1. After that mod operator with equal to sign. So 5 mod 3 is 2. Then x is equal to 5. Again, we are reinitializing value to 5. So this is AND operator assignment. Then this is OR operator assignment. Then XOR. This is right shift operator. And this is left shift operator. So we will discuss this in detail with the help of code. So this is the output of above example. So let's understand this with the help of code in Visual Studio. So let's deep dive into the assignment operator. So let's debug the application first. So the initial value of x is 5. So output would be 5 for this statement. After that, we are doing addition operation. So 5 plus 3 is 8. So the output would be 8. After that, 5 minus 3, that is 2. After that, multiplication operation, that is 5 into 3, that is 15. So output would be 15 only. Now we are making division. So the output would be 1. Yes, for division, it is 1. After that, we are using mod operator. So 5 mod 3 is 2. Yes, it is 2. Now let's deep dive into the bitwise AND assignment. So what is the definition of bitwise AND assignment? The bitwise AND operation compares corresponding bits of two numbers and returns 1 if both bits are 1. Otherwise, it returns 0. This is the binary representation of 5 number and this is the binary representation of the 3 number. So let's read bit from right side. So the first bit of 5 is 1 and for 3 is also 1. So that's why it is considered as 1 only. After that, second bit is 0 and second bit for 3 is 1. it's not 1 1, so that's why it is considered as 0. Similarly, third bit is 1 and third bit of 3 value is also 0, so it is not matching, so that's why it is also 0, not matching, because as per the definition, both bits should be 1. Otherwise, it would be considered as 0. So that's why rest of the bits are considered as 0. And the final output would be 1. If you convert this binary number into decimal, then it will show 1 value over here. So let's go ahead. Yes, the output is 1. After that, we are reinitializing value of x to 5 only. So here bitwise OR assignment we are doing. So as per the definition, the bitwise OR operation compares each corresponding bit of two numbers and returns 1 if at least one of the bit is 1. If both bits are 0, it returns 0. So the condition is at least one bit should be 1, then only it would be considered as 1. So this is the binary representation of 5 and this is the binary representation of 3. So the first bit is 1 and this is also 1. So this is OR condition. So both are 1. So it considered as 1. In second bit for 5 it is 0, but for 3 it is 1. So that's why the condition is true. So it would be considered as 1. Here also third bit for 5 value is 1 and 0 for 3. So it is OR condition. So in this case, it is also considered as 1 only. So the final output is this, and this is the binary representation of 7. So it will print 7 on console. Again, we are reinitializing value to 5 and using bitwise XOR assignment over here. So as per the definition, the bitwise XOR operation compares each corresponding bit of two numbers and returns 1 if exactly one of the bit is 1. The bits are different. If both bits are same, both 0 or both 1, the result is 0. So the condition is if both bits are 0 or both are 1, then it should be considered as 0 only. The condition is either corresponding bit of two numbers and returns 1 if exactly one of the bit is 1. So again, for this operation, this is 1, this is 1, both are same. So it would be considered as 0 over here. Again, 0 and 1. So both are not matching. So it would be considered as 1. Here also, third bit is 1 and third bit of 3 value is 0. So it would be considered as 1. And rest of the bits are similar. So it would be considered as 0 only. So this is the output of XOR. So let's check the value of it. So it is 6. So the output should be 6 over here. Yes, it is 6. Now let's discuss right shift assignment. So as per the definition, when you shift right, the empty positions on the left are filled with 0 and the rightmost bits are discarded. So again, we are initializing value to 5. So this is the binary representation. So as per the definition, the empty positions on the left are filled with 0 and the rightmost bits are discarded. So in the right shift, these 3 bits are discarded and 3 zeros would be added at left side. So let's understand this. So here, when you shift right, the empty positions on the left are filled with 0 and the rightmost bits are discarded. So these 3 bits would be discarded and 3 values would be added at left side. So in first shift, this is the initial value. So we will delete this value and add 0 over here. So this is the final output after first shift. Then in next shift, this would be deleted and 1 0 is added over here. So the final output would be this. And in third shift, so this is the initial value. After shifting all the bits up to 3, then this is the final output and the value would be 0 over here. Yes, it is 0. So let's understand left shift assignment. When you shift left, the empty positions on the right are filled with 0 and the leftmost bits are discarded. So it is exactly opposite to right shift. So here, this is the binary representation of 5 and as per the definition, leftmost bits are discarded. It means that these 3 bits are discarded and 0 would be added at right side. So let's understand this. So this is the initial value. So in left shift, this value would be deleted and 1 0 is added at right side. So this is the output. So in next shift, this bit would be deleted and 1 more 0 is added over here. Yes. And after that, in third shift, this 0 would be deleted and 1 more 0 is added over here. So this is the final output after third shift and it will print 40 value on console. Yes, so the final output is 40.